Okay, ladies and gentlemen, so as you can see here, right, um, there's a very nice physics problem. We love physics here, okay? And this is the one problem that I've had trouble with ever since the very beginning. So I'm going to do it on stream, just to practice a little bit, to practice. Where's my pen? Uh, I'm sorry about that. Ladies and gentlemen, please give me a quick second. Okay, now I have my drawing tablet pen. There we go. Okay. Oh, no, okay. So, what I'm going to do, right, I'm going to pull out the annotation. Can I annotate anything? Please? Oh, there we go. That helps so much. Okay. Let's change that to paint. Okay. So, we are going to shrink down the problem a little bit, right? We are going to overlap, and we're going to have paint biggened, right? And we're going to have the actual, oh no. And then we're going to shrink this one down a little bit. Okay, so, well, as you can see here, right, oops, wait, brushes, color 1, there we go, right, so, we're at the building, right, 20 floors tall, right, each floor, right, okay, we're going to pull up Google now, okay, right, we're going to pull up Google. How tall is a floor? Right, about 14 feet in meters. Alright? Because, floors are disgusting these days. So, 4.3 meters. Right? Is it, wait, like, story. It's kind of hard to type with a pen in my fingers. So, 4.3 meters, right? Let's go back to this. So, that's 20 times 4.3, right? So, we're going to do the math here, right? That's 80, right? And then plus 0.3. 0.3 times 20, alright? This is a very fine problem. It's going to be 6, so 86 meters tall. Alright? Now, we're on to the actual problem, alright? Ball's released from the 20th floor of a building, right? Goes down for 3 seconds. And it has passed 4.3 meters per second, right? That was the first floor, so it's going to be seconds squared. So 4.3 meters per second squared. Now we're going to do a funny little equation called distance final equals distance initial plus velocity initial times time plus half the acceleration times time squared. If we plug those numbers in, it's going to be d final equals 86 plus velocity initial, that's 0, times 3 seconds, alright, times half acceleration, alright, so that's 4.3 times time squared. But you see, we can't do that equation. Do you want to know why? Because we don't have time. Oh, wait, no, we do. I did a little goofer. Okay, there we go, right? So, 86, oh wait, I'm supposed to do a plus there, right? So technically this would be minus if we want to do the equation like that, right? So, plus 0, plus, right? Half times, right, so let's just do 3 times 3, right? That equals 9, very nice. Now, 9 times 4.3. Let's do the math here. So 4 times 9, that's going to be 3, and then a number less, the number added on to that equals 9. So that'll be 36. And this, 2.7. 38.7. I'm sorry if I'm writing this sideways, alright? Let me adjust this real quick, right? Okay, there we go. And also, this drawing tablet's inside my desk at a weird angle. Okay, so now we have 38.7, right? Now we're going to divide that by 2, okay? So let's divide that by 2 real quick, right? So 2, right? Look at this. We could do 1 here. So that's 2, and that's now 18. 9, alright? 0, that's 7. And that'll be 0.35. Pretty simple, right? Okay, so 19.35. 8, 6 minus 19.35. Now, let's do that math, alright? That's going to come out to, well, let's see, 80, so that's 70, and then that'll be 60, but then it'd be 67. But technically, it'd be 66.65 meters, right? A beautiful number, might I add. Okay, so now that we have 66.65 meters, what do we do? Well, we can take 86 and subtract 66.65 to get, well, 19.35, right? Or, and then that would be our final distance that it fell in those 3 seconds, right? But how many floors is that, might you ask? Okay, so let's see. 4.6 equals what? 1 floor? Okay, so let's divide this by 4.3. Sorry, 4.3. So let's do the math. 4.3 and 19.35. Oh, I have to move this thing. You know, I'm just gonna turn that little thing off. All right, 0.35. Okay, so as you can see, 4.3 already goes into 19. But you know what? For the sake of time, I'm just gonna do it a little goofy. Okay, I'm gonna pull out my phone, right? 19.35 divided by 4.3 equals 4.5, right? Or we could take the bigger number. We can take 66.65, right? So what did we get for our 19.35? Well, we got 4.5. That doesn't seem like a right answer. It did not fall 4.5 in 3 seconds. It fell 1 floor in 1 second, which is 4.5 meters. Okay. You know, let's take 66. 66.65 divided by 4.3. You know what we get? We get 15.5. Now, let's go back to our equation really quick. All right. Let's go back to our fun little equation. So it can be between, right? It can be between 3 floors and 0 floors. Why is this cord over here? Okay, it can be between 3 floors and 6 floors and 7 floors and 11 floors. Wrong. It can't. It's not how it works. Because you know what? You guys see all this math here? Why is my mouse not appearing like ever? Okay, you know what? There. Control Alt Delete. Oh no, I was holding the wrong thing. Okay. Control Alt Delete. You know why this is all wrong? Because apparently we don't even need that equation. Alright? So what you can do is take, okay, 4.3 meters per floor. That means 4.3 meters per second squared, right? You can take that and you can use another equation, right? So you have the current ratio of acceleration, which is 4.3 meters per second squared, right? Which is acceleration, equals v over t, right? Simple as that. So our velocity, or at least velocity final minus velocity initial in this case, all right, equals what? What is the velocity, you might ask? Well, you see, it starts off as velocity 0, right? So we're going to do velocity at 4.3 and then minus 0, and this is at 1 second. So 4.3 over 1. Yeah, pretty simple. Now what do we want to do if we want to increase that by 1? It doesn't say. Okay, you know what? Fine. We'll use another equation. Alright? So we've already used Dicky. We've already used Author. Let's try using Vicky. This was the distance equation. Boring. Acceleration equation. Boring. Let's try this. Okay? Velocity final equals velocity and... Whoa, but wait. We don't need the velocity. So, let's go about this one more time. Alright, distance. Alright, pretty simple. Equals vt, or v over t, but we don't need velocity, so we need something without velocity. So, with distance initial, right, we'll just call distance initial 0 this time, okay? Okay, pretty simple. Now what we're going to do, right, is plus v0t, which is obviously going to be 0, right? Then plus half at squared, right? We don't need any of this at this point, okay? We don't need any of this, so d equals 1/2 at squared. Okay, now we know our acceleration. It equals 4.3 meters per second squared. Alright, now we're going to do this. 4.3, right, times 1/2. That equals 2. But wait, there's a 0.15, alright? Now we're going to take 9, because 3 times 3, or 3 squared, equals 9. So, 2.15 times 9 equals what? What might you ask? Okay, so let's take our 18 real quick, right? From this, right? Now let's distribute that. Okay, so now we have 0.15 times 9. It's going to be less than 9, of course. Okay, so let's take this. So 0.9, right? Now let's add this one. 0.5. That'd be 0.45. So in reality, we have 19.35. Now let's take 19.35. 19.35 divided by 4.3. It's 4.5. The answer's not 4.5. It's like 9 or something. Where are we getting these numbers? You know what? You know, fine. How about this? I change the numbers. Control A, Control Delete. I'm going to make each floor in my perfect world, okay? One floor equals 3 meters, alright? This is my perfect world, not yours. It's mine now, okay? I don't care about what measurements you have, okay? I don't care. I need to solve the problem, okay? So, let's do this. Distance final equals 1/2 times acceleration, which is going to be 3 meters per second this time, because, you know what? 1 meter, 1 floor. Alright? Oh, no, sorry. 1 second, 1 floor. Alright? Or technically it would be distance on top, right? So 1 floor over 1 second, right? And all that over 1 second. So that's this per second. 1 floor per 1 meter per 1 floor per 1 second per 1 second, right? So 3. And then we're going to put what over here? 3 seconds squared. Okay, so 1.5 times 9. What does that get us? I don't think it's the right answer. Because you know what we get? We get 9 plus 4.5 equals 13.5. That's not even close to 11. Okay, fine. You know what? We can play this your way. Alright? So, let's go back to the tab, right? Let's go back to the tab, alright? So, the math says a ball is released from the 20th floor, right? I'm going to draw a little picture, alright, for this, right? I am going to pull this up on the other tab and pull it off to the side. I'm getting quite annoyed. There's someone outside making a really squeaky noise and I'm about to blow up. I'm gonna spontaneously combust. Okay. So. Okay, I'm actually gonna blow up this time. So. Over here, right? We have this. Right. Released from the 20th floor of the building. And after 1 second. Right? It reaches the 19th floor. Right? Directly outside. These are evenly spaced. This does not look like correct, but anyways, we ignore that, okay? The air resistance is negligible. That means Alright, so 20th from 20th floor, right? Drops down to the 19th floor in 1 second. That's pretty nice. How many floors would it fall in 3 seconds after it is released from the 20th floor? The answer is 9. Why is it 9? Let's try doing the math. Alright? Now, so 1 floor, alright, equals roughly 12 feet. But for those of you who hate freedom, that's about 4.3 meters. Alright? So, let's take a look at this math, right? 4.3 meters, right? It's the measurement you're supposed to use in physics, but you know what, that's fine, right? Let's take a look at this equation, right? We have distance final, distance initial, velocity final, velocity initial, acceleration, and time. Right? These are all little variables that we might or might not need along our way. So, distance final, we don't know. That's what we're looking for. Distance initial, right? So, 4.3 times 20. 4.3 times 20 equals 86. So we start on the 86 meter mark. Right? Pretty simple. Velocity final. We don't know. Velocity initial. 0. Because it is released from the 20th floor at seconds 0. At seconds 1, it reaches this. Alright? Acceleration. So, now we're going to assume acceleration is 9.8, right? It's technically 9.81, but we don't care about that little puny 1, right? I will admit, it is average sized, that 0.01, but we're not going to talk about it. This is physics. Time. You're given 3 seconds, alright? So at our ratio of, alright, 1 second, alright, equals 1 floor, or 4.3 meters, right? Let's take a look at the math, alright? That means 4.3 meters equals velocity, right? That is at second 1. So, that means 4.3 meters per second squared equals, oh wait, I forgot to do this, equals the acceleration constantly, right? That's nice. That's nice and all, right? But how do we solve this? How do we solve this? You might want to ask, right? So we're going to do this, right? Distance final equals distance initial plus velocity initial time and plus half acceleration squared, AT squared, right? So let's do this equation. 86 plus 0 plus half 4.3 3 squared. You can't see that. Okay, so 86 plus, and then let's see. So 4.3, all right, 4.3 cut in half. That is 2.15 times 9, right? Times 9. That'll equal 19, right? So this plus 19.35. What is that? What is that, you might ask? Well, that's 105.35 meters. So let's divide that now, okay, by 4.3. Okay, what do we have? We have 24.5 meters. You've gone into the ground. You've gone into the fucking ground at this point. How the hell did you go from here to here in 3 fucking seconds? I'm gonna actually just blow up. I'm gonna blow up. And ladies and gentlemen, this is why you should take physics, alright? This is why you should take physics. I'm so happy right now, okay? I'm so happy. I'm so happy. I'm actually just so amazed at how things can go so well, you know? This is my pencil, right? This is my physics homework, okay? I'm just kidding. No, I have an A in class. I have an A in the class, right? But it's an A minus. Right? That's not good enough according to my parents, right? We're gonna like one little. We'll make a circle here, right? We're gonna make a circle here. We're gonna cross here and a circle here, right? Right? It's mostly correct for the most part, but you see this one little cross, right? You see this one little cross right here. Yeah, that makes this little pen of mine turn into a freaking dagger. I'm gonna be cutting myself at the end of the day because this is the most simple problem, and I know the answer. I know the answer. Oh, I know it, but it does not know me. Oh, I know. I know my name is Heisenberg, but this problem does not know mine is. Alright, so, let's just use proper logic this time, okay? So, 20th floor, right? That is 86 meters, right? So, at the 19th floor, right? Which will equal minus 4.3 meters. That will be 81.7 meters at 1 second. Simple enough. That's one floor, right? It's gone down a total of 1 floor. It's beautiful, right? Isn't it? Isn't it just beautiful? We have all the things we need right here, but yet I still can't seem to get the answer. Okay. We are going to try and find this out, right? You have 2 more seconds. 2 seconds, right? For how many floors? 8 floors, apparently. So, we're going to take the ratio of 1 to 1, alright? And we're going to find out how 2 to 8 relates to that. Okay, so 1, 1, 2, and 3, right? So this needs to somehow equal 8. Let's see. Okay, so if we take maybe 2 and 3, no, that equals 6. So it's not 2 and 3. Right? Maybe 3 and 5. Well, 3 and 5 does exist, you see, because then that creates a very nice pattern. How does it do this? I don't know. Does it add on another 2 meters per second each time? How the hell does it do that? Does it add on 2 floors per second each time? I don't know, because I don't know. I am going to combust spontaneously. Okay, you know, fine. It's all fine. Okay. I'm so mad. I can't. My finals tomorrow. I'm not okay. I don't want to do this anymore. I want to go home. Okay, you know what? Fine. Okay, let's do the math that my old physics teacher taught me. Okay, so distance equals half AT squared, right? So half A, right? And then times T squared. But we don't need T squared, apparently, he says, right? That's a little bit weird, right? But you know why? Because distance, 1 floor, equals half acceleration, and then times 1 squared. Doesn't matter, right? So 1 equals half A, alright? That means 2 meters per second equals A. What the fuck? Because this isn't a meter. No. This is not a fucking meter. Alright? This is a fucking floor. Alright? So 2 floors per second. 2 floors per second squared. Right? So let's times that by 2, okay? Or let's times that by 4.3. 4.3x2. When did the acceleration turn from 4.3 to 8.6? When did the acceleration fucking double? What the hell? Okay, you're fine. Let's bring the time back, okay? So 3 squared equals 9. Excuse me, but what the fuck? Now you might be wondering, but in Carl's You're the Gamer, doesn't this make sense? Isn't this basic physics? Basic physics, my ass. How the hell did you get 8.6 from 2.3 when there was no 2? Where was the 2? The 2 appeared out of my... You know, we're not going to talk about that. We're not going to talk about that, okay? So we all know it's 9 now, right? So let's try to solve for 9. Half AT squared. We don't like that, apparently. So if we do the math, right? There is no D0. There is no V0. So both those are exempt. D, alright, so we're going to take all this, we're going to delete it, and we're going to bring back the brush. Alright? I'm infuriated at this point. Okay, so D final, alright, so D final equals half AT squared. Let's try to solve for A, alright? So first we have to get rid of the multiplying factors, right? So distance over 2t squared equals A, right? So that means 86, right? We've seen the math before. 2 times 3, and then squared. So 3 squared, right? We can assume that 3 squared, and then that would be 9, and then that would be 18, right? So 18 and 86. So 86 divided by 18 equals 4.777 with a bar over it. We're getting closer now, okay? 86, alright? 86 divided by 18. I'm doing it on my calculator now. Yep, it comes out to that math. So, we've gone from 4.5, right, to this. A slightly better answer. But is it acceptable? Is this alright? No. We still have another couple of floors to fall. Now you might be wondering, where does the other couple of floors come in? Alright, I know, alright, that velocity final divided by 2 equals velocity average. But this is not velocity! Where on earth does this come in? Where does the velocity come from this? I hate physics. I'm gonna blow up. I'm gonna explode myself. Okay, you're fine. Control A, Control delete. Okay. Brushes, okay? So, let's go this, okay? D final equals D initial plus V0t plus half AT squared, right? So already know this does not equal anything, right? This can go die in a hole. This does not exist. It's only a figment of your imagination. Just like a lot of things. Just like physics. Physics doesn't exist. Neither does Isaac Newton, because he never had that apple drop on his head to make him go crazy. All that remains is a small little black hole that's going to consume the entire Earth and make it a void. So, okay. Let's take this. But wait. The values have to be in meters. So, 86 minus 4.3. Okay, so that's 81.7 equals 86 plus nothing plus half A. Well, what is A, you might ask? We're going to leave it at A because, actually, no, we're going to put it at 4.3 because that's the correct answer. And 3 seconds squared. Okay? So we're going to minus this, right? Minus this, blah, 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 right? That comes out to negative 4.3, right? Equals half 4.3 times 3 squared. Now, be wondering, hey, that doesn't add up. That doesn't match, alright? Well, what we can do here, right? This is one floor. This is one floor. Apparently we can't do anything with it because we're all slaves to reality and nothing can help us. Alright, so we're going to do multiplication stuff now, okay? So we're gonna delete all this, right? What happens, right? 0 gravity at 0 seconds. Alright. 10 gravity at 1 second. 20 gravity at 2 seconds. 30 gravity at 3 seconds, alright? That means 30 gravity. 30 G's, alright? That's a pretty big number. I gotta say. Okay? Now then. Let's look for something in my notebook that tells me the answer while actually giving me the answer. Alright? See, I don't solve problems for the sake of solving problems. I solve problems for the sake of learning them. Alright? I'm trying to get a good grade, not because I want to know the answer. I don't want to know that it's 9. I already know that it's 9. I've known it was 9 all along. Alright? Time equals 0 turns into time 1, right? So, x is now equal to distance, okay? X final equals x initial plus v0t plus half at squared. Alright, so 19 floors, but wait, it's not. It's the fuck? You're supposed to do this in meters, not floors? You know, for the sake of math today, we're gonna do it in floors. We're gonna say 1 floor is 1 meter because we're all midgets. Not a single woman will want a short, nice guy. 19 equals 20 plus 0t plus half a time is 1 in this case, squared, right? So we can cross this out. So now we have made this, right? Negative 1 over here equals half a and then times 1 squared. So we can cross that out because that's just times 1. So what is this? A and half, right? Multiply that by 2, multiply that by 2. A equals negative 2 meters per second. It doesn't make sense to me, honestly. It really doesn't. Alright, so let's erase one last time. Alright. This is our final mission. Alright? So the ball goes from here to here. F20 to F19. 1 second. Alright? 1 second. And in 1 second it travels 1 floor. But for some fucking reason goes, yes, my acceleration is gonna be negative 2 meters per second squared. Where's the 2 meters? Where's the 2 fucking meters? We're gonna ignore that now. We're gonna ignore that now. Okay? Okay. So, distance equals half at squared. Half times 2, right, equals what? 1. 1. No longer needed. Time squared. 3 times 3 equals 9. So the answer is 9. Motherfuckers, go learn physics yourself. Don't ask the guy on YouTube to teach you, because he won't know how either. Alright? As my last gift to you, I'm gonna blow myself up. I'm really considering just exploding at this point, alright? But, you know, because you viewers of mine, right, you guys are so nice to me. I'm kidding you. You guys are awesome. You guys are my only reason to keep going at this point. But, yeah, I don't really enjoy, physics at this point, right? I'm just kind of dying right now. Alright? It's not enjoyable at this point. I'm actually just gonna implode. You know, it's the norm. Anyways, ladies and gentlemen, boom. Actually, I can redo that way real quick. Anyways, ladies and gentlemen, I guess, it is my time. I'm going to, blow up. Yeah. Jesus Christ, there's an ad. Okay, yeah. Ladies and gentlemen, I guess, it is now my time to go.